Okay, here was all. I got another bloody brownout. Got this smart meter and this smart grid technology is supposed to prevent this from happening. Some bloody technology, eh? 164.7 volts. Yeah, that's not enough to run anything, but modern stuff runs okay. Let's see if the TV runs on that voltage. It probably won't deflect properly because it hasn't got enough current from the transformer in there to get the full deflection. Yeah. It's only filling up to here, not enough volts.
But, according to Nikki...
Interesting, it still works at all at that voltage. They all still work okay at that voltage. 150 volts now, it's gone down. Yeah, that's just pants. Bastards. Ah, bastards. Oh well, that's some modern technology for you. Well. Okay, viewers of the power's still browned out. Yeah, it still smells like a third world country from that bloody stuff I nicked in the microwave yesterday. Let's get my multimeter out and check the power here. Most probably going to be the same. So, plugged in, power on, see what the AC voltage is. Hey, it's gone back to normal. There you go, power's back to normal there. Right, power off. Unplug the multimeter, safety first. Okay, viewers, well, when I tested the power at the caravan, I had full power, but the house has still only got 180 volts. As you can see here, phase A has dropped. I've only got B and C potential, no A potential. So the phase that our house is hooked up is a weak phase that has dropped. So we'll hold that. 52.1 volts on the first phase, put on 14.99 amps, 180.6 volt in the second phase, putting 0.02 amps. The third phase, 237.5 volts. So 180 and shit all on that phase, and put full voltage on that phase. Interesting. Yeah. 23,948.8 kilowatt hours are pulled so far. Back to the other menus, different on this one. There you go. 56.9 volts on that one. Pulling that much. 180 volts on that one. Pulling that much amps. That one, 237.4 volts on that one. 1 power factor. Doesn't tell me the current, must be pulling anything. Now viewers, so I'm going to take the cover off this little water sensor here. I wonder if I can get a little arc on there. That'd be cool. Someone asked what this actual fuel filter came off. It was off a 2007 model, as judged by the date code. That was the original fuel filter too. So it was a 2007 model Nissan Navara. Made in Austria, not Australia. Alright, let's get this thing opened. Okay, viewers, I got the little cover off this. I got some hardware on here. Light on. Got an electrolytic capacitor, little transistor there. It's got BL-P65 with xenon diode, some resistors, and another capacitor. So those brown things are capacitors. That's the resistor. 1R5. I got a couple here, I can just read that. 1AA1, 1AA3, 000, 1AA1, and the capacitor. Another xenon diode there. Next to this capacitor, electrolytic. And we've got this little chip here. It's got CCA9200, WDS 9850, 800, and 08LF 0701. 8th week of 2007 this module was made, and that chip's got 1st week of 2007 written on it. So this last one is positive. We've got some creepage gaps there, spark gaps of some sort, in case something, I don't know what sort of diesel wasn't the petrol, so I'm not sure I'd able to use those in the diesel. Put that last pin there is positive in, and these two here will go back to your ECU. So it must be a negative for this one. One of these is your signal, it sends back to the ECU if you get water. This thing here sends a complex signal back to the computer. Interesting. See if I can desolder this board and solder some leads on there and get some arcs off that. Even on my little ignition coil thing, I can make a little adapter, and that will seal into the back of a chamber, and spray some petrol in it, stick a tennis ball in it, and fire it off. That'd be cool. Little spark cap for a combustible bloody cannon. That'd be nice. It's under where that circuit board was. Now I can solder some HV wires into that. Have a little arcing bit. There's a circuit board, good quality substrate. If yours, it's all done nice and insulated with hot glue. Fits perfectly inside this bottle. There's glass cup bottles, perfect, look at that. Holds it quite nicely. Might leave it in there. Have another electrode sitting in there. Well, let's run this on the NST and see what happens. Get a little 10 kV NST out so I don't risk arcing through the hot glue inside there. I'll put the hot glue gun away, that's all nice and cool. Let's hook up the NST. Let's see if it arcs. Hopefully it arcs in the right spot. In 3, 2, 1. Oh, look at that. Hot glue worked wonders. Ah, we've got flames. Unplug the safety first. The insulated thing, hot glue worked perfectly as an insulator. Beautiful. Let's try it out so it rises to the tip. I might stick that, it's probably not going to work because I want a plastic, but if I seal that in the vacuum, I want a tube on that and seal that in the vacuum, I might get a nice little plasma between those. Unplug safety first. Yeah, it didn't arc on it, that's good. Yeah, the plastic's all burnt up. Yeah. I wonder if it'll work on my ignition coil. See how well that hot glue insulates from that. Let's see it arcs. Oh, look at that. No arcs underneath either. Beautiful, we've got an arc and spark. Oh, look at that. Pretty. Burns it a bit there. Nice little spark gap that. Zoom in there. Little spark gap. I'll stick it over it and pull a vacuum. If I stick it over there and pull a vacuum and see what happens. Find something to go over that. I smell that plastic burning now around the end of those electrodes. I can zoom out a bit here. There are we. There are we. There we are. Bit of production bottleneck here, so I'm just experimenting. I can see we've got a spark in a bottleneck. Now I'll put something over that and suck all the air out. Probably doesn't even get warm. Interesting. Nice little spark show. There we go. Works quite well. We'll turn it off. Unplug safety first. And the IGBT in this driver is quite happy. I'm quite happy with this driver. But I do like the one Anthony high one voltage one rules made. That's quite powerful. I've changed the frequency on it and everything. With wire wash you can clean this electrodes up. Alright, let's see what else we can try. Let's just see if this bulb or the CFL lights up. I'll wait and zap the base because that's actually a good working CFL. Oh, cool. Pretty. Pretty. See the battery's happy. Doesn't even have to touch it and it excites a bulb. Turn the bloody camera light off. And you can just see it, the light's being excited. In the present, so the light's getting excited and shocked. Interesting. Alright, power off, unplug safety first. It'll still work, let's plug it in. I'll plug that in there. Let's power it up. Bit of a mess up here, I've got to arrange all my cords. All my cords get tangled, start to get a little bit frustrating. Alright, plug it in. It'll still work the same. Yeah, still lights up the same, you can see it's still trying to warm up there. You can see on the base where all the phosphorus set when they made it in the factory. Saved up like that, sprayed it. When they twist these bulbs, they have like a little thing that sprays phosphor in there. And it sits up like that, it all sits and drains back out, and there's where it all sat and dried out. Anyway, that'll be enough for now. Thanks for watching.